early morning wake-up call in Southern California. 4.2 magnitude earthquake.
California, where the governor is asking the White House for help.
Yep.
We're having an earthquake.
We're experiencing very strong shaking.
California's seismic activity and the San Andreas Fault. An in-depth exploration. California, known for its seismic activity, has long been a focal point of geological research due to the looming threat of a major earthquake along the infamous San Andreas Fault. Numerous factors influence the occurrence of earthquakes, including tectonic plate movements, fault interactions, and stress accumulation. While these are well-established mechanisms, recent scientific inquiry led by researcher Riley Hill has introduced a novel perspective: the potential influence of nearby bodies of water, specifically dried-up lakes, on seismic activity. Understanding earthquakes and tectonic activity. To comprehend the potential connection between dried-up lakes and earthquakes, it is crucial to grasp the fundamental principles of seismic activity. Earthquakes occur due to the movement of tectonic plates, vast sections of the Earth's crust that are in constant motion. These plates interact along fault lines, fractures in the Earth's crust, where stress accumulates over time. When the stress exceeds the strength of the fault, it is released in the form of an earthquake. The San Andreas Fault, a major fault system in California, is a prime example of this phenomenon. The San Andreas Fault is not a single continuous line but a complex system of interconnected faults, capable of producing significant earthquakes. California is home to several other major faults, including the Hayward Fault, the San Jacinto Fault, and the Calaveras Fault, each contributing to the state's seismicity. The role of dried-up lakes in seismic activity. Dried-up lakes, scientifically known as playas or ephemeral lakes, are bodies of water that experience fluctuations in water levels due to various factors, including precipitation changes and human activities. Recent studies have explored the hypothesis that these lakes might influence seismic activity. When these lakes dry up, they potentially impact seismic activity through mechanisms such as reduced lubrication along faults due to water loss. Moreover, changes in pore pressure within the Earth's crust caused by the disappearance of water can alter stress distribution along faults, potentially affecting their stability and triggering earthquakes. Lake Cahuilla. A case study on seismic influence. One specific case study that has garnered attention is the ancient Lake Cahuilla, located in what is now the Coachella and Imperial Valleys. Researchers have proposed that the filling and draining cycles of Lake Cahuilla played a significant role in stabilizing the southern San Andreas Fault. Major earthquakes along this fault line seem to coincide with the lake being either full or in the process of filling, suggesting that the weight of the water exerted pressure on the fault, potentially releasing accumulated stress and preventing seismic activity. However, as Lake Cahuilla gradually dried out over the past centuries, the tension in the fault increased, akin to stretching a taut rubber band. This heightened potential energy in the fault has raised concerns about the possibility of a significant earthquake occurring in the region. Seismic hazard and risk mitigation. The significant implications of these findings, particularly in the context of the seismic hazard posed by the southern San Andreas Fault. California's population is concentrated in highly populated areas close to these fault lines, and this demographic distribution makes the potential impact of a major earthquake a paramount cause for concern. Historically, the region has witnessed catastrophic earthquakes that resulted in substantial loss of life and extensive property damage. These events serve as stark reminders of the vulnerability of the population to seismic hazards. In response to these challenges, seismologists underscore the critical importance of comprehending the accumulated tension along fault lines and the necessity for implementing effective risk mitigation strategies. These strategies are fundamental for minimizing the impact of future seismic events and safeguarding the well-being and safety of the communities in this seismically active region. By advancing our understanding of these seismic processes and proactively planning for potential disasters, we can work toward a more resilient and prepared California. Balancing environmental rehabilitation and seismic risks. Important point regarding the direct implications of these research findings for environmental rehabilitation efforts, especially in the context of the Salton Sea. Environmental restoration initiatives, which aim to address issues like pollution and shrinking water levels, play a critical role in the region's sustainability. However, these efforts must be approached with a careful and well-informed strategy, taking into account the associated seismic risks. The potential for significant changes in the water level of the Salton Sea to trigger seismic activity underscores the need for a cautious and balanced approach. It's essential to strike a harmonious equilibrium between environmental restoration and the safety of the communities residing in seismically active areas. This consideration emphasizes the importance of thorough risk assessments and comprehensive planning when implementing environmental rehabilitation projects. By doing so, stakeholders can work towards both environmental sustainability and the mitigation of seismic hazards, ensuring the well-being and safety of the affected communities. Continued scientific inquiry. You've aptly highlighted a crucial aspect of this research. The hypothesis regarding the connection between dried-up lakes and seismic activity is indeed fascinating and potentially significant. However, it's imperative to acknowledge that this field of research is continually evolving. Scientists and seismologists are actively engaged in thorough investigations, employing a variety of methodologies such as field studies, laboratory experiments, and advanced computer modeling. The ongoing research is instrumental in providing a comprehensive understanding of the intricacies of seismic activity in California. It allows for a more informed assessment of the role of secondary factors like dried-up lakes in the larger context of geological forces. Through these ongoing efforts, the scientific community can refine their knowledge and potentially enhance our ability to predict, prepare for, and mitigate the impacts of seismic events in the region, ultimately contributing to the safety and resilience of the affected communities. Summary captures the essence of the topic succinctly. The ongoing research into the influence of dried-up lakes on seismic activity highlights the complexities of understanding earthquakes. By approaching this subject with caution and relying on scientifically supported evidence, scientists can integrate their findings with broader knowledge about tectonic plate interactions, fault systems, stress accumulation, and geological processes. This multidisciplinary approach is vital for comprehensively understanding seismic events in California. Continued scientific inquiry is essential in unraveling the intricate relationships between environmental factors and earthquakes. Ultimately, this knowledge will empower communities to predict, prepare for, and mitigate the impact of future earthquakes in this seismically active region, ensuring the safety and well-being of the people living in these areas. Thank you for watching another episode of Space Odyssey. While you are still here, don't forget to like and subscribe.